Okay, so we're going to be doing 207 course schedule. Essentially, you are just trying to figure out, given the number of courses and the prerequisites, if it is possible to, take the courses that are said in the prerequisites based off the prerequisites, right? So, if we look at this case, you have two courses, and then you have course 1, which needs course 0 as a prerequisite. And in this case, you can do this because you can take course 0 and then course 1. And then for this one, right, we can see same thing, two courses. However, take course 1, you need course 0. And for course 0, you need to be able to take course 1. So like there's that loop, and that is basically impossible, right? Because I can't take course 1 because I need course 0, but since in order to take course 0, I need to take course 1, right? Obviously, I have that conundrum. And, that this pattern that we're seeing right here, this loop, is essentially what we're going to be using to solve this problem. If we find a loop, then that means it is not possible to do this course path, and we'll return false. And if we don't find any loops and we can traverse through everything, then we'll return true. And so the way we're going to do this is with a graph, and basically we'll have a graph and just again check if all the nodes are not in a loop. So the way we're going to do this is with an unordered map. So I'm just going to jump right into it. Unordered map of, so the first one will be the int, and the second one will be a vector of ints, and we'll call this graph. So essentially what this graph is it's going to be the integer is going to be the course, and then this vector of integers is going to be the prerequisites needed to take that class. So now we can go ahead and populate it. So we can just loop through prerequisites and add them to our unordered map. So for int I is equal to 0, I is less than prerequisites dot size, and then plus I. Right, so we're going to be looping through the whole prerequisites, and now we'll add our values to the graph. So graph, right, graph at the first, the prereq, or the class, so at prerequisites I1. So again, we're looking at this class, so class 0. We will push that back, push back, and then we'll push back to prerequisites. I cannot spell. Let me do this. Prerequisites of I0, right? So we are basically setting the key to be 0. So like if we're just using this as an example, right? The key would be 0, and then within 0 would be 1. So we have our graph from there. So from there, now we can traverse through the graph and look for loops. And the way we're going to do this is with DFS, depth first search. So we're going to have, our two essentially vectors, which are going to track the path, and the the visited nodes, so if they're visited or not. And the reason why we can use vectors instead of something like a set is because of this num courses. We know how many courses there are, so we're not constantly adding to the set, or we know the number of courses, so we know how long our vector could be. So I'll have a vector bool called visited, and then I will initialize that to num courses and then false. So essentially all the visited nodes, so in this case, first case, I only have 2, or in both cases, I only have 2, right? And those will both be set to false. And then I'm going to copy this, and I'm just going to call this the path. So, and that is also set to false. So nothing in the path has been visited yet, right? So now I'm going to basically loop through the array and, or not the array, sorry, loop through the graph and check each key value pair. So for auto, I'm just going to call it I in graph, and I'm going to make this pass by reference. There we go. So essentially what we're going to do is we're going to have int course, this will be our course number, is equal to I dot first. So again, this one, the first index is that name. And now we can check to see if we have a loop or not. So if we haven't visited course, so if we didn't visit this course number, right? And if we also, so this is where we implement DFS, and if there's no loop, so this DFS will check if there's loops. And what are we going to need for, our parameters? So we're obviously going to need the course number. We're going to need our visited and path vectors, because those keep track of, if there's a loop or not. And then we're going to need finally our graph. So if this is the case, and we'll again implement DFS. So if we are not visited and there's a loop, then we want to return false, because we found that it's impossible to, have these types of courses, right? This type of course schedule. And if we make it out of it, we return true. So this means we traverse through the whole thing without any issues. So over here, we can add a Boolean function DFS, right? We can take the int course, then we can take in our 2 vector booleans. I'm just going to do this. Visited, and then path. We make them pass by reference because we obviously want to modify them. And then finally our graph. So unordered map int com vector of ints that we made, and then we call that graph, and we also make that pass by reference. Where's the %? There it is. Okay, so what's the first thing we do in here, right? To check. Obviously, we're going to check first, is there a loop? So if path course, which means when we come in here and whatever we're checking, right, if it's true, then obviously return true. So we're returning true because, right, if we're in here and this is true, so we have this and true, we didn't visit and it's true, we want to return false. We've found our loop. So then our other bit is if visited course. If we've visited this this prerequisite before. We don't care about, we don't want to look in it again. So return false. So if these two conditions aren't met and we're not kicked out of this loop, then we should set our things to visited and that we're looking in this path. So path course is equal to true, and then the same is with visited. So visited course is equal to true. So now these two are set, right? If when we come back in here and we check the path, then and it's true, then obviously we can kick out the loop and say false. It's impossible. So now from here, right, we just traverse through the graph and we see all of the connected nodes and see if, you know, there is that that loop that could occur, because this is recursive. So let's just loop through the loop. So if auto I in graph, right, we will in graph course, so all the prerequisites in there. We'll do if DFS for at I visited path graph. So again, we're just going to be looping through here constantly. If we find one, then we return true. So again, if we find our loop, right, and this returns true, then we'll come here, return true, which will come in here and return false. And that's how we essentially get in there. Now, if we go through all of this and we reach the end and we don't find any loops, then the path is valid. So we want to stay visited just to, you know, if we come back in here again through a different course, we want to say, okay, we visited, this path is safe. So, but we want to change this. So we'll change the path to say that it's false. Oops, all caps. False, and then we want to return false too. So this way, we're basically saying path is safe, and we do not need to go in here and return false. So let's run it. Test cases pass, and then if we hit submit, there we go. Nice.